Solving system of equations by substitution, part 1. When solving a system of equations by substitution, the rule or the um, task that we're trying to achieve is to arrange the equation so that you have a variable with a coefficient of 1 on one side and everything else on the other. And then we will substitute this into the other equation and solve for the remaining variable. So that's the kind of gist. What I'm going to show you and examples that I have um, will be more suited for substitution. Now, there's another way to do this, and it's called elimination, but there will be another video to teach that method. But the first one that we'll look at is these two equations. It's a system of equations. Note that the top equation is in standard form and that the bottom equation is in slope-intercept form. And the coefficient of the y is a positive 1. When this is the case, we can go ahead and what we want to do is we want to take all of the expression that is equal to y, and we would need to substitute it into the y variable here. So what we're going to do is we're going to say 8x minus 3 times something equals 5. Now that something is right here because this y, if we substitute all of this in for this y, then what we have is an equation in terms of all x's, which allow us to solve for the x. So that's what we're going to do, and that's how we're going to do it for all of these that follow. This is predominantly for, we'll use substitution, hence the name is solving a system by substitution. We are getting an equation with, in terms of a variable equal to the rest of it, and that variable has a coefficient of 1. Now, in solving this, we will have 8x. Now, this is a negative 3, which will distribute 3 through. So that's negative 3 times negative 4x, which is positive 12x. Negative 3 times negative 15, which is positive 45, equals 5. Now, what we have created in this situation is basically an opportunity to solve an equation, a one-step or two-step equation. But we first must be mindful of what we have all on one side. You know, our objective in solving an equation is to get our variables on one side and numbers on the other. But as you can tell, we have 8x and 12x here. They are like terms. So when we have like terms on the same side, we combine them. So that gives me 20x plus 45 equals 5. Now, we can move our number to the other side. So 20x equals negative 40. Now that we have our variables on one side and numbers on the other, we can ask ourselves what is happening to the variable. The variable is being multiplied, so we will need to divide both sides by 20. Now, that leaves us with x. Let's see. Scoot that up a little. X equals negative 40 divided by 20 is negative 2. Now, we have found what the x value is. So now that we know what the x value is, we can substitute it either into the top equation. We could put negative 2 in for this x and solve for y, or we can use the easiest equation because the bottom one is already solved in terms of y. We can substitute that x value straight in for this x and solve for y. So y equals negative 4 times, we said x was negative 2, minus 15. Well, negative 4 times negative 2 is 8, minus 15. So y equals 8 minus 15 is negative 7. Now, we know what x is, we know what y is, but we have x equals negative 2, we have y equals negative 7. We need to finish this by writing an ordered pair. So the solution to this is negative 2, comma, negative 7. Now what that means is this. If we were to graph these two equations, we would expect them to intersect, or we would see them intersecting at negative 2, 7. Now, let's do another example. That was number 1 again, but let's look at this one. Again, we have a linear equation in standard form and one linear equation in slope-intercept form, which lends itself to being solved by substitution quite nicely because the coefficient of y is 1 over here. So everything is solved in terms of one variable, and that's what we mean by solved in terms of one variable. One variable is on the left side, everything else is on the right, and the coefficient of that variable is 1. Now, what we're trying to achieve is solving the system by substitution. So we're going to write out the first equation. We're going to take the top equation. Now, note that we've got y equals negative 4x plus 7. If we take this negative 4x plus 7 and substitute it in for the y in the top, then this is what we get. And then we'll finish the equation out with equals 17. We basically, all of this in parentheses right here is the y. And we said that y was equal to negative 4x plus 7. So we can substitute that value in for the y, which puts everything in terms of x. Now, let's go ahead and bring our 5x down. We have a positive 4 times everything in there. So positive 4 times negative 4x is negative 16x. Positive 4 times 7 is 28 equals 17. Again, we're going to have to look and see what we have multiple things of per side. And in doing that, we will see that we have two variables that are like terms, 5x and negative 16, and we will add them together. That will give us a negative 11x plus 28 equals 17. Let's get our variables on one side and numbers on the other. So we'll subtract 28. That leaves us with negative 11x equals negative 11. Okay. Divide both sides by negative 11. That leaves me with x equals negative 11 divided by negative 11 is positive 1. Now that we know what x is, we can take it and substitute it back into the x variable. We know x is 1, so we could either substitute it in for this x variable and solve for that y, or we can use the easy equation, which is in slope-intercept form, and put that 1 back into this x, which will allow us to solve for the y. So in doing that, we have y equals negative 4x. Well, I said we was going to substitute, right? So I went ahead and wrote the variable without substituting. So we have negative 4 times 1 plus 7. Negative 4 times 1 is negative 4 plus 7. So y equals negative 4 plus 7 is 3. We have an x value and a y value. That means that if we were to graph these two equations, one in standard, one in slope-intercept form, we would expect that these two equations would intersect at 1, negative 3. The solution to this system is 1, negative 3. It's an ordered pair. This concludes part 1 of solving a system by substitution.